Hello, everybody, and welcome to today's session. It is the introduction and overview session for the certificate programs in Python for algorithmic trading and computational finance. We recently also added a comprehensive class about Python for asset management. My name is Yves. I'm founder and CEO of the Python Quants and the AI Machine, as well as your program director. Yeah, today's session is not a typical training session. It is just a session to give you a broad and sometimes detailed overview of what to expect from the program, to learn more about the organization, the sequence of the weeks in the program, and you will also see a couple of cases from the program. So quite a bit of code will be shown as well, but you can relax and lean back. It's not about internalizing. What I'm going to show is more to whet the appetite. We have quite a long agenda. So here you see, after a brief introduction, I want to give a broad overview of the program, briefly talk about Quant Platform, then the classes themselves: finance with Python, tools and skills, Python for financial data science, Python for Excel and databases, a little bit of NLP, then AI in finance, which has become part of the core of our programs, alongside also techniques from reinforcement learning. And what I said already before, Python for asset management is now another cornerstone in our program that we have added for this round. In the future, this will be separated out into a separate program. Python for algo trading, Python for computational finance, these are the core classes in the programs, or maybe you do both in the form of the Platinum package. And then we come to the case studies and the demos. They just like show you code from the different classes, a few examples, also a little bit about setting up infrastructure for Python. And then we go into the study plan, just a brief overview and a discussion of what to expect for week one. And afterwards, we discuss guiding principles and how we want to implement them and how we want to support you with regard to the best experience and the highest return on investment on your involvement here in the certificate program, in the forms of reviews, exercises, user forum, also brand new addition, Discord server, where we add another element to building a community around our core topics and around our programs in this regard. Right. So that's the agenda. Let's get started. You see quite a bit to cover. The introduction is just meant to give you a brief overview of what we do, where we're coming from, what our core expertise is. Everything is centered around Python for finance. The Python Quants says it already, I guess. We provide services for financial institutions, run training programs, run platforms, have open sourced a couple of libraries. I personally have written a bunch of books on the topic. And of course, we provide the certification in cooperation with the university here for our certificate programs. And we also run events. Usually they used to be on site. And of course, given the recent situation, most of them have been obviously digital. Then we have the AI Machine, another company and another platform. It's for the simple deployment of Python-powered, AI-powered algorithmic trading strategies. So it solves the last mile problem in algo trading. But there's so many platforms and tools and packages out there that allow you to do backtesting. But once you decide to go live, this is then where the hard work begins. This is what the AI Machine is about. Here, the 2-minute summary for the program, and just checking audio. I don't see any issues with regard to audio. Maybe you can confirm that you can hear me, because there have been a few questions or comments in this regard. So the 2-minute summary, just for you as reference. I don't want to go any deeper. This is also just for reference. Don't want to go through my background here. It's just for those who are interested in what I've done in the past, where we are coming from, and who you will be working with primarily over the course of the program. So I mentioned already the books that I've written. So these are my 2 quant finance books. By that, I mean that finance comes first and Python is a means to an end, and that the quant finance topics are implemented for execution, right? So derivatives analytics with Python is kind of general with regard to numerical methods in the areas of options pricing and options hedging. A list of volatility variance derivatives is a little bit more specific, obviously, as the title already suggests. So this is the main book in the series of my books. It's the reference work Python for Finance, which is, I think, of interest to anybody working in finance, even if it's maybe not really concerned with options pricing nor algo trading. So whatever you do, if it's financial data science somehow related, then this is the go-to book. Which covers in different chapters, different topics that are of importance, as I said before, for almost everyone, I guess. These are the 2 books that came out in 2020, Python for Algo Trading, Artificial Intelligence in Finance, and they built the basis, for example, to the respective classes in the program, therefore more details about the contents later on. So now coming to the program, just the brief, broad overview. Here it's 16 weeks, many hours of instructions, lots of content. So sometimes it can already in the first week seem a little bit overwhelming what we provide you with, but you know in our programs you have in general indefinite access to your personal resources. So when you say, well, there are 150 relevant pages for this topic and you just read 75, no worries, you can read the other 75 pages later on, and you can reread the stuff that you have read during the program as well. So there is no rush in that sense. We know we provide a little bit too much, I would say, over the course of the 16-week program, but you have all the resources together to also study self-paced during the program as well as after the program. We have had many delegates that have revisited the materials and the updates multiple times. Also, the codes, we try to make it reproducible and readily usable, right, in the form of Jupyter notebooks, but also additional codes. It's quite a bit of stuff that we provide you with, but I think this is what we are striving for, to give you the highest benefit for the program that you participate in. Here, another view where you see, well, of course, there's lots of stuff, but I think the beauty from my personal point of view, and this is why we have set it up that way, is that you can access all the resources in a single place. That's the Quant Platform, right? There you find all the videos, there you find all the codes, you find texts, you find additional resources, you have the user forum. So it's one place, one go-to source that you can access in order to work with the code. So most of the codes, for example, most of the code is executable on the Quant Platform, but not everything. So some stuff is supposed to be executed on your local machines, but this is what we want to do. We don't want to have you locked into our world where we say, well, you should stay here, and we don't want to let you go. To the contrary, we want to empower you. We want to teach you skills that empower you in the end to set everything up on your own infrastructure, be it a local infrastructure, be it scalable cloud infrastructure. No matter what you choose, in the end, you should be able, I mean, you have acquired the skills to set it up and to manage to work with it on your own. That's our goal, but you have the platform available. And I think our programs have become more and more timely over time. So I still have left here quotes or articles, news articles from Financial Times here, for example. This is from 2018, so a little bit dated. So what we are doing here has started a bit earlier in terms of that banks, financial institutions require coding skills, and in particular Python programming skills, right, on a level not seen before. When we started with Python for Finance, most financial institutions simply neglected Python as a language and the approaches that were already available back then with regard to financial data science, let's say. But we've come a long way, and it has become a competitive topic in the sense of that if you neglect it further, this can be a competitive disadvantage. Therefore, the big banks, the smaller hedge funds, other financial institutions, they all train the people these days in the coding practices that have become so relevant, right? So computer programming skills is what has become here a must-have, they say, right? It's not enough to have Excel and PowerPoint anymore on the resume. Maybe for an MBA who is looking for a job in a management consultancy, for example. But even there, I've given a bunch of trainings in management consultancy firms where the data science teams apply the very same techniques these days. Maybe they have been even a little bit earlier than their clients. Usually they are when they are good ones. So it has become the key skill, I would say, these days. There's lots and lots of data. People are talking all day about the data that is there. But of course, you need to have the right tools and the right skills to work with all that data. And then we have, of course, the trend with regard to artificial intelligence and machine learning, deep learning, etc., right? So job seekers with expertise in AI, machine learning, and data science are among the most in-demand candidates in finance. 2019 Bloomberg, so a trend that also has started a while ago. And one of the reasons why AI has become such a core topic in our programs, we have alone 24 sessions, 1.5 hours plus lots for additional resources that are concerned with that only. And then we have noch specific topics such as reinforcement learning that come on top in this area, right? So Quant Platform, I said it already before. We have one platform that provides you with everything that you need. So for example, if there is a recording of a live session such as the one today, you will find it shortly afterwards on the Quant Platform. If there is code that is used that accompanies a live session, you find it on the Quant Platform. If there is on the study plan a module mentioned with regard to recording and then maybe some reading, you find the stuff on the Quant Platform, right? So this is true to a large extent. Sometimes we also work with external gists, for example, and other resources wherever there is a better solution available, and by better I mean more efficient for you. Then we leave the platform, right? But the Quant Platform is actually the source. So you log in, everybody should have already an account and credentials, then you find latest video, you have the user forum, you have the courses, which means the text, you have all the trainings that belong to your program here in a single place. So for reference, here behind this particular slide and this screenshot, there is the link to the overview video of the Quant Platform, some, I don't know, 11 minutes here or 12 minutes, which explains the basic workings. I will also show a few elements in this regard, but I don't want to go too deep. This is documented, and you have the user forum if you face any issues, whatever technical kind is. For example, in the user forum, there is a board which is called Quant Platform, right? So, and also you can search the user forum. Maybe somebody else has already asked a related question to your issue, and you might find the answer immediately there. So, but in general, it should be self-explaining to play the videos, to open the codes, etc. Right? Finance with Python, the first class. This is the basic class, basic in the sense that it originated in the requirements of many people, some of them with a strong finance background, but no background in programming whatsoever. Some of them with a stronger programming or data science background, but maybe with no or little knowledge about finance or experience in finance, right? And this class is meant to level the playing field in the beginning, that it teaches finance, traditional finance, I must say, from scratch, not too broad, not too deep, but they get quite a good coverage, and it introduces at the same time related math, not on a high-level mathematics, right? It's kept as simple as possible, and it introduces the Python idioms that are required to implement this. So this is like the three elements of this particular class, and what we cover there is asset pricing, option pricing, hedging, optimal portfolio choice for an agent, expected utility maximization, complete markets, incomplete markets, Dynamic economies, there we call, for example, the monomial option pricing model by Cox-Ross-Rubinstein, 1979, or a bit of Black-Scholes there. So it's like a walk through finance history, you can also say, by the means of a bit of math and a bit more of Python programming. And you will see when you stay on that level, Python is really easy to understand, and it makes like for a completely different experience that I would have wished for when I studied this quite a while ago, I must say, many years ago. I was so fascinated by these topics and by the theories that are covered there, but there was no real language or computer tools available to work with it, to implement it, and to visualize, for example, certain aspects. But with Python, we have the tools available, and that's the approach of the class here. Gentle introduction to finance Python and a combination of both. This is what we get started with, right? We have text, we have the videos, the recordings with additional resources, plus we have the code, right? So we do Jupyter Lab. So at this stage, I want to briefly show Quant Platform, which you all should have access. So when you open it up, I'm here, what I see in a different account. I have multiple accounts. Here there is the latest video. So this is the latest recording in this account which you have access to. 17th session, you see Python for asset management. This is like more of the larger classes that we have. I think it's the one with the most modules and recordings currently available. And down there, it gets started with the forum posts, the latest ones, where you get like an overview, right? There's something related to Wonder, there's a little bit of general pandas implemented, there's something about the artificial intelligence in finance book, right? Also a question with regard to codes, where to find them, and then there you see all the boards. I mentioned the Quant Platform board, so when you have questions with regard to the platform itself, you can ask a question here, the user forum. Simply click on that and you should be good to go to post your question. On the upper left-hand side, you see the menu popping up. So user forum itself has its own menu point, but you can navigate from here, the dashboard, or you go to the user forum. There we have the courses. And when we talk about finance with Python, I can click here of finance with Python. Another tab opens and you see the HTML version, which was last updated not too long ago. On the left-hand side, you see the table of contents. So when there is, for example, in the study plan, a reference which says chapter 3 of finance with Python, you see here chapter 3, right? And then you can navigate and you can read it here. Or this particular class also has a PDF accompanying it, because some prefer to read such text, for example, on a tablet like the iPad, etc. Right, so that's the first element. When we have a look at the slide deck, that's here the first screenshot. Then we have, for this class, we have also the training itself. This is also called here Finance with Python. When I open this, it doesn't show Python for asset management, obviously, but I now see the different modules with the recordings. So this was the complete class was refurbished, updated just recently. So there are now 6 modules. There used to be 4 only, but now we have 6. Going in a little bit more detail, you see here codes, you see a link to a slide deck, and when you would get started with the first video, you simply click here on the video. Then you can, for example, jump forward and go through the resources, right? So this is the second part of the slide. See here, Finance with Python, that will be the video. Here, what you have, when I close this again, this part, see also Finance with Python book 01. So when I maybe go to Finance with Python, I open the very first one by clicking on it. So it now opens Jupyter Lab, where you can execute the code that accompanies this module. It takes a little while because you work with Docker here. So for everybody, we have a containerized environment, right? And therefore, when a new Jupyter Lab gets initiated, set up, then it takes maybe a few seconds. So in the book itself, you find the code. in the module, in the recording, the code is explained. And here you see for the very first how I execute the code here, right? So as simple as that, without you having installed any Python environment locally. So now at this stage already, because you see here, it indicates that it doesn't save the Jupyter notebook. So I can also change the code here and do some stuff, but it will not save it, because what we provide you with here are reference benchmarks, and they are read only, so that you always have the original code, right? So when you have worked in this, like let's say this is my changed version, for example, right? And when I want to save it here, file, you see here, this is grayed out, right? Save notebook doesn't work, but I can go and do, for example, save notebook as, and then you see here a long path, which is basically not for us too relevant. I can simply delete this path there and can save it. Maybe do it from the other side so that we see what I delete. Simply get rid of that path and save it, and now you see that it has saved. So this is one thing that you need to consider, that we provide you with benchmark notebooks, right? They are read-only and they will stay as they are, or we update them, right? So when we update them, you get the latest version when you click on this file. But here, you now see that this is not active anymore. I can get back to here my, where did I thought I would have saved it now in the location, but maybe I have not. Let me check where we are. Well, I seem to still be here, and that maybe I have done a mistake with the save here. So let me do it again. I was expecting it here, right, at this stage. So it has been saved, but currently I obviously made a mistake here with regard to where I wanted to save. Probably it is here. Oh, it is. Oh, I saved it in trainings. I just see that I saved it in trainings, and here it is. So it was in another. I wanted to save it in the my root folder, as you saw me checking for that, but I didn't delete the final path here. So it's now here where I've saved my version. So usually I would save it in my root folder. But the major message is, by adjusting the path when you save it, you can persist your own notebooks in this context, or you can simply leave it as it is and download it. For example, this is also possible when you say, well, I've worked on that, and for example here, when you do a right click, you can download all the resources to your local machine. So a right click, download every notebook that you have worked with here, that you see with here, can be downloaded to your local machine, right? So this was it with that. But there are also other resources that are related to FinPy, and you find them here. These are the six Finance with Python notebooks. They are exactly the ones on which the book is based. So this is the code that is used when the book gets rendered, right? So there is like a process behind that, and here you get like access to these. But what I mentioned before holds true here as well. This version cannot be saved, but I can save it in another location by adjusting the path when I do my save as. And you have seen, you must be careful with regard to how you choose the path, otherwise you might not find it, as was happening to me. All right, yeah, these are the resources that are reflected in the other classes as well. Sometimes there are changes. Not every class, for example, has a full text, a full book. Not every class has notebooks. Sometimes, like the tools and skills class, there are mostly snippets, code elements, bash scripts, etc. They are stored in a different fashion, right? But all the classes, they have the recordings for the sessions with the related resources and links to the slides, etc. attached. So when we talk about Python for financial data science, it's the same structure. When we talk about Python for asset management, it's the same structure, but Python for asset management, for example, doesn't have its own text. Python for financial data science has its own text, right? So these are the difference, slight differences, but once you get the structure, you will have an easy time to find your way through the set of resources that we provide you with. So I'm closing all that. I currently don't need this anymore so that we can move on here in the slide deck. Tools and skills, a class that I mentioned before, where I said, well, maybe the resources are presented differently. And this is a class that teaches you how to set up environments, how to use Docker, how to use cloud, both on Mac and Linux as well as on Windows. So in the beginning, you will find here differentiation between the two major platforms. And once you have your basic infrastructure ready, we go to the development side where we show how to edit code with Vim. Why Vim, you might ask? There's so many other tools. If you have your favorite code editor, for example, locally, that's perfectly fine. But if you want to work in the cloud, maybe your local editor won't help you a bit, and you might need something to edit code in the cloud. And this is where Vim comes in handy. So I don't do everything locally with Vim. I do several things with Vim. There was a time when I was working with Vim exclusively. For example, I know the learning curve is pretty steep, but even if you only master the most important 5-7% of the functionality, you can use it already properly in a cloud setup to adjust scripts or whatnot. Right? Then here, lightweight tool chain for editing, logging, debugging. A bit about testing, right? Doc test, unit test, what is Git version control and how to work with version control. And once we have mastered these basic elements of the development part here, we can go to distribution, because this is helpful in every context, even if you work for yourself alone. But if you, for example, are working in a corporate context or with a group of like-minded, or if you want to, for example, publish an open source package, then this part here about distribution is important. So how to package your Python code, how to write proper documentation, how to do code hosting, for example, on GitHub, or in particular on GitHub, I'd rather say. And there's a case study which combines all the elements that we see here together. So many elements that are important for Python development. And when you work with Python, it might not be directly Python related. So sometimes there are sessions where there's no Python code developed, but it helps you with the development and the writing of your Python code, right? So we cover here topics such as Python, Docker, DigitalOcean, and Jupyter notebooks. So now that we're here, I want to do a quick demo with regard to setting up an infrastructure. So, and I do the demo now, and I said it already during the introduction. Don't worry about the details. This is just to whet your appetite and to show that it's not some black magic to use these tools there. But I want to do a demo and to show from scratch what it entails to set up a Python environment. And I do this from the shell here. This works on Linux in a similar way, and on newer Windows versions, it has become pretty close. So we are not too far away anymore with regard to the platforms. And here I'm going to use Docker because on my Mac machine here, I have, of course, quite a bit of Python installed and all my tools are there, etc. Right? I run here Jupyter Lab, for example, but I want to do it from scratch. And Docker helps me in that. I can run a Linux operating system here in a container, as it's called, in something like a virtual environment, which is hosted on my machine, but which has a different operating system. So I have here, just for reference, in the accompanying gist, to which you have the short link as well. I copied this line here. This is meant to be executed on the shell, but it requires obviously that Docker is installed, which is mostly a relatively easy thing. And you see when I execute this, I'm already here. Before it was work, Mac live session that we are in. That's my username, Eve, right? Now that I've executed that, I'm in root at cert. So, and for everybody who's worked with Linux, that's like a typical thing. I'm logged in here as an administrator in a containerized environment. So I go to the root folder, and I have my live folder mounted here as a volume. So live, these will be demos that I later want to use and to show, right? So that's for later for the demo, but this is also part of the demo where I show you how to set up. So first thing that we typically need to do is to update our package index. That's a little bit of housekeeping, so to say. I go and install a little tool that I need, wget, to retrieve a remote file. I could do many more things now, but this is the minimal, so to say. And we recommend in general to work with Anaconda. So Anaconda has a bunch of installers. Here are the ones for Windows. Here are the ones for Mac. So if I would now work on my machine here with the Mac operating system, these would be the installers. But since I'm in a Docker container here and the Docker container runs Linux, I need to pick the Linux installer, and I copy only the link address because I want to retrieve this now and save it in my container, right? So getting back, wget, that's the reason why I installed this, right? To retrieve this file, it downloads the installer. It's now in my root folder, and I can execute this via bash Anaconda. It asks me to read carefully the end user license agreement, right? So we should do this. I've done this a few times. Now, if I accept it, yes, I accept. The installation location, I confirm. And it is now installing Python with, as we say, some batteries included. There will be SQLite, for example, a database, and if you see there are a few packages that get installed. It's not only Python. Here is Python, but there is obviously quite a long list of other things that get installed here that are useful, right? But it's still minimal. For those of you who have maybe heard or worked with Anaconda, Anaconda comes with a bunch of packages that you probably won't ever use, right? And here I can control which packages are getting installed. So now I say, yes, please do conda init. And at this stage now, it says, yeah, everything is okay so far, but I don't have Python yet. But when I restart bash, you see the prompt changes. This looks like on my Mac now, base, root, etc. And when I now type in Python, I have Python 3.8, the version I have chosen, and I good to go in this context. But I want to install maybe a bunch of other packages. Let's say I want to install NumPy as one of the major packages that we are going to work with for numerical Python. Here it now says, oh, well, if you want to install this package, here are a few more packages that get installed. It takes a bit, depending on the internet connection, a bit longer or maybe a bit faster. There's one large package, and maybe Jupyter Lab. So conda install Jupyter Lab, the major tool that we would use in this context. Again, it communicates as before with the server, checks what is to be installed. Then it comes back with the message, oh, these are all the packages. Are you really sure you want to install them? You see, it takes a bit because Jupyter Lab requires quite a few additional packages to be installed. Quite a long list, we can agree, I guess. And I say yes, because this is what I want to have. And it installs the major web-based Python environment. And we are good to go, at least to some extent. I mean, I've just installed NumPy and one tool, but it's already enough to get started. So good to go. And I start now Jupyter Lab, but here in this context, and I don't want to go into the details as of now, this is explained in detail in tools and skills, for example. I say allow root because as a system administrator, it's dangerous, not secure to run such a server, but I explicitly allow for that. Then I say on all IP addresses, and I have just one port, and I need to specify it here. This was during the startup where this was specified. And let's see, it executes, right? And down here, I can now pick this with a token. The token replaces a password. And I use this long, oh, I just saw that I was missing one number, so this wouldn't have worked. The 3 at the end was missing, so the token was incomplete. Now I hope I have gotten all the elements. Yeah, the 3 was the final one. And Jupyter Lab is starting up. I have installed it. You see here Anaconda. These are the notebooks which I have mounted. And here, for example, I can start the console. It takes a few seconds. Let me increase this for better readability. And for example, I can now do import NumPy as NP. I have installed NumPy, then I can do something like random 20, and I draw 20 random numbers, right? So this is, I would say, relatively simple. Of course, you need to get used to working with the tools that I've just shown. So Docker needs to be installed. You start a Docker container, I do a little bit of house cleaning, then I install Anaconda, then I use conda install to install the packages plus the tools that I want to use, and I'm good to go. And that's the basic setup. There are a couple of details that might be relevant depending on your use case or your target scenario, but this is basically how it works. So it's not rocket science, as they say. And we show for the different platforms how this works, also for the different environments, for example, in the cloud, how you can work with it. So maybe I simply leave this here. I won't work with that later on. This is done locally. But that's already basic setup and would work in the cloud, for example. Yeah, exactly the same way, we can say. This is what this class is about. I've now used Docker, I've installed Python, and there was Jupyter. In the cloud, as I said, would be the same. I can even set up a cloud instance, run Docker there, install Python, and then end with Jupyter. Right? So this is what this all is about. Here, the resources you have seen, the videos as they are presented with the links, for example, and additional resources. And there are gists that contain the tools or scripts or tips and tricks or references, cheat sheets, whatever we provide is then a reference there. Python for financial data science. This is, I would say, the major non-core class because it covers so many important topics that are used and reused over and over again in the other parts, right? So here it's the basics about Python data structures, types and data structures. NumPy is covered here, what I just used. Data analysis with pandas, one of the major packages for our time series management, for example, in finance. A little bit of OOP, which is useful in many contexts, how to do visualization, working in this context with financial time series. This combines in particular pandas with matplotlib, how to do efficient input-output operations, so fast reading of data, fast writing of data, fast crunching, processing of data, performance Python. So in many corners of the financial ecosystem there, we have the need to simply execute stuff fast. Think of Monte Carlo simulation for in risk management, let's say, right? This needs to simply be done in an efficient way. And here Performance Python shows a bunch of packages as well as approaches to speed up your Python code, sometimes even getting to comparable speeds when compared with C or C++. Right? But with much less effort involved. This doesn't work always, it would be too nice. There's no free lunch in this regard, but for certain algorithmic structures, such as nested loops, there are pretty good tools available that make that stuff pretty fast. Mathematical tools, I have a quick demo for that prepared for later on. This time around for this cohort of the certificate programs, I want to put a bit more emphasis on mathematics because we simply need it in all corners of what we do. And this is also a bit driven by requests from past delegates. They said, well, yeah, I would have enjoyed a refresher of certain topics, let's say linear algebra or solving equations or a bit of differentiation and integration, etc. So this is what we will put more focus on this time around for the certificate programs, right? Statistics, machine learning, obvious important topics for our discipline, right? The resources, you see them here, same structure as before. You have the text, you have the videos with the resources, plus you have Jupyter Lab with the respective codes, notebooks, resources, etc. For easy execution and download if you want to do this on your local machine. Python for Excel. Excel is still an important tool in the industry, our financial industry, right? But it might not be of primary importance for everybody. But we have a class about how to best combine Python with Excel. So it's basic idea is that we have the analytics power of Python and we want to access this power from an Excel context by, you see it here, an example, by maybe just clicking a button and then a Python script is executed, which is called via VBA, and then we get the results from Python instead of just relying on arcane VBA code and slow performance and the working around the limited capabilities of Excel as a data science platform, right? But as an interface, it does a great job, right? If we want to come up with some GUIs that even non-Python programmers can use, this is kind of like a nice way of combining this. Speaking of data and data science capabilities, databases are an important topic. This is also I would say, an optional support class, not of primary interest to everybody, but it's a class which gives you an overview of popular SQL and NoSQL databases and of a couple of solutions that are Python specific. So we speak of or talk about MySQL, SQLite, MongoDB as an object store, right? PyTables, which is pretty fast binary store for storing large amounts of structured data, for example, right? So numbers, let's speak of numbers, time series, etc. SQL Alchemy is a Python package which makes backend integration of databases kind of agnostic, pretty nice approach. Pythonic is a columnar data store, which is pretty fast and has powerful compression mechanisms built in. There are different examples, comparisons, speed is of the essence, and also, for example, the storage space that is required for similar data sets. So for some, this might be pretty interesting or even required, right? There's still so many relational databases in place, and also SQLite, which comes with basically every Python installation. It's not just a toy database. It's a pretty powerful database, and you don't need to have the quote-unquote biggest use case in the world to work with such databases. Sometimes it's just a few lines of code and you can use already the full power of such a established and powerful solution. Also here, the resources a bit different. Everything what is presented here is supposed to be executed in a cloud setup or a Docker container setup because, alone the installation of MySQL and a couple of other things there and working with larger data sets. Here, the idea was to avoid any mess up with your local installation. So at this stage, when you get started with this class, you should have covered already setting up cloud infrastructure, how to set up the Python infrastructure in the cloud, etc. But this starts anyways in the beginning, and then you can make easy use of the resources that we provide, like installation scripts, which then do the trick, hopefully, basically on its own, right? And then you can go through the resources. NLP becoming more and more important. This is a relatively short class, but what is covered in this short class is already so helpful, right? You would see how to work with regular text, with HTML documents, and how to parse them, how to do summarization, how to come up with word clouds, and quite a bit more. So although this is a short class, we cover quite a bit of ground, and you can use the elements and the scripts, the files that we share there to your benefit, I think, in many different instances. So pretty interesting topic, because Python is not only in combination with pandas and NumPy so powerful with regard to structured data, but it is absolutely on equal footing also with regard to unstructured data. So NLP is also one of the major strengths, let's say, of Python as of today. AI, one of the topics, the hype topics, the trending topics in finance, right? And there is a reason why I've written this book. It was an outgrowth actually of teaching classes that we have done in the past. And the book has come out last year, right? So it's, as the name says, all about AI in finance, but it focuses mostly on market prediction and trading. So that's the major focus there. And we have available for you in this context 24 module sessions in 2 different classes. We have put the one class in the optional column, as you will see in the study plan, because the one class is mostly concerned with building neural networks from scratch. So if you're really interested in how this all works and what this entails to build it at least to a, how shall I say, at least to a certain level, maybe not even blue belt level, orange belt level, by far not black belt, right? Black belt would be Keras TensorFlow, for example, or PyTorch, right? This is far, far away. But if you want to get like a more intuitive understanding of what is going on with deep learning models, deep neural networks, then the optional class is good. But the core is based on the book, and this is all practical with regard to universal approximation theorems. The code, the structure exactly the same as before, plus you have the text available for your reference, obviously. So reinforcement learning for finance, I mean, the topic in and of itself is so interesting, and it's now getting more and more important also for finance. So it all goes back to the, I mean, not theoretically goes back, but the recent hype goes back to breakthroughs, mostly achieved by DeepMind, the company, English company that was acquired by Google, where they used reinforcement learning agents to play Atari games, and many of them at superhuman levels. This was one of the major breakthroughs, and down there you see like the popular story about AlphaGo, where there is also this widely watched Netflix documentation, which is available on YouTube for free. So really fantastic topic. And because I'm so intrigued, and many others are so intrigued by how this works and how this might work out in a gaming context, we cover, although the class is called Reinforcement Learning for Finance, the first examples that we're going through are related to gaming, right? Where we first see the algorithms such as Q-learning applied to their original environment, and with that background we then move on and translate what we have learned there to a trading bot context. So we want to build trading bots that learn in a similar way as compared to the agents that learn to play games. Actually, one of the first examples in this regard uses the same deep Q learning agent that is used to master the game of card pull to trade in a simulated financial environment, right? And from that point on, we take it then more and more into the financial discipline. So here is the here are 2 links to the to some codings there. This is with regard to the Lunar Lander. This is an example that we do that you can then implement on your own. Maybe some of you recall or are in retro gaming. I recall this playing myself when I was pretty young. Right? And here the reinforcement learning agent has learned to land the lander here, right? The spaceship between the 2 yellow flags. It's not the best agent in the world, you see. It struggles quite a bit with the commands there, but in the end, this is of course a successful run. It will be able to land there. A much better agent would solve the problem here much faster. Right? But this is also without using too much trickery there, relatively small code base, and now it's getting to the landing, right? So these are examples that we are covered there, that we're going to cover in this class. And yeah, successful run, I don't know, some 400 commands, actions have been seconds. Yeah, 410, finish here, 410, the recording. There's another one, this is Mount Car. Similar problem, but not as involved as the lunar lander. Resources, as before, we have recordings, we have slide decks, different ones, right? Explaining the notions, the algorithms, everything involved, and then lots and lots of code in the form of Jupyter notebooks. So by now, I think you have completely internalized the structure of the resources. So that is the newest class. Python for asset management, as said before, this will become a separate certificate in the future. So there will be a certificate in Python for asset management in the future. And here we cover basics of risk and return in finance. Mean variance portfolio theory is at the core. Obviously, I can say maybe capital market theory, capital asset pricing model, arbitrage pricing, alternatives to MVP theory, such as risk budgeting, risk parities covered there, and then also how to work with AI and machine learning approaches in asset management context. So there's also Black Litterman, which is covered intensively, which is then combined with machine learning and AI approaches, etc. So you saw it before, there are like 17 sessions, modules that come with this particular class, right? So from traditional mean variance portfolio theory to AI for asset management, that's the basic idea of this whole class. There alone, I don't know, there are 25, 30 notebooks that come with this class with many, I think, interesting analysis if you are even remotely concerned with asset management investments, maybe on a personal basis, but maybe or in particular on a professional basis. This is then your go-to resource if you want to implement these approaches in Python. Also, just like to build a bridge, for example, to Python for financial data science, where we have covered a certain topic in an interactive Jupyter Notebook context. Then there are also implementations done based on OOP, on better reusable, on a better reusable code basis. So it's not only about presenting it, it's also sometimes to get it to a, let's say, pre-production level where you could make use in a more general context than just a Jupyter notebook. So the core of the core is portfolio selection according to Markowitz. And here you see the problem formulated, right? So we have the expected return, we have the volatility based on covariance, right? We say we invest 100%, and in general, as the benchmark case, we don't allow for short sales. Here it's just for a simple case of 3 assets only, but this can of course be done for many assets, and examples include like 30 stocks of the German DAX index, or other indices with constituents, or a mix of time series data that we use, but all reproducible based on fixed data sets, so that you can, without having API trouble or whatnot, that you can implement. But of course, I always say that and recommend it. You can work in these contexts also with your own data sources. So if you have data sources that are of particular interest, it shouldn't be too difficult to replace the data sources that are used. So it builds on topics, as I said before, from Python for finance. The AI parts are mostly based on AI and finance, adjusted to asset management, and beyond the standard theory. So when we cover, for example, risk parity, risk budgeting, this is a book that I recommend. It's well done, let's say. It's nicely written. It's in LaTeX. It's easy to read. I don't say it's simple, but it's easy to read. Accessible from my point of view, not program implementation oriented, but it explains the theory with many numerical examples in a nice way. So this is a resource, and I've checked many resources in this regard that I started really liking and relying on. Yeah, that much about Python for asset management. Then, of course, one of the cornerstones at all. I think still today most people come to us for Python for algorithmic trading, which I'm pretty happy about. Here we have the book about the topic on which the class is based, right? And here it expects, of course, to have the foundations available before we get started. So these classes now, computational finance, algorithmic trading, etc., they expect that you are on a certain level already, but the whole program when you've had a look at the study plan, is structured that way, right? Foundations first, and then we get started with the core topics such as vectorized backtesting, prediction-based trading, event-based backtesting, algo trading, and here getting started with real-time data and streaming, covering the platforms. We cover 4: Wanda, FXCM, Interactive Brokers, and Gemini for crypto trading, and automation is an important point. So you can do backtesting all year round, and when I think of backtesting platforms, Quantopian jumps to mind. Unfortunately, they had to shut down recently, but I personally always saw one problem with Quantopian, that it didn't show a proper path to deployment of the strategies. Backtesting is fine, but what is the value of backtesting if you don't have a venue to really trade your strategy in automatic fashion? And this class has the one and single and major goal to empower you by teaching you all the skills required to deploy your strategies that you have backtested before. So we don't want to stop and say, oh, well, nice strategy. These are the metrics that we have derived, and here are a bunch of platforms. No, you need to combine all this, and automation and review, maybe the block is well too small. But this is really, I would say, the hard part and the important part. And we try to, based on the practice modules many other exercises, etc., to make this possible. It is not easy, but it's also not too difficult, right? It requires a little bit of a different or additional skill set to, let's say, only backtesting and research, but it can be mastered. And our program, I think, has all the elements that you can master these parts as well. So we start with the infrastructure. Financial data is required for anything that we do. You want to implement your strategy code, you want to backtest it, you need to connect to the platform, to the broker, you need to implement the trading code after the connection, and then hopefully you're able to automate the whole story, because otherwise it would be discretionary trading and not necessarily automated trading in this context, right? So the AI machine, what I introduced briefly at the very beginning, is basically intended to automate many of the steps that I've shown before. In particular, when we talk about automation and trading code, what the AI machine does is you implement, you formulate your strategy in pure Python code, and then if it's done correctly, which requires the following a couple of rules, etc., then you can backtest this code, but you can, without changes to the code, you can deploy the strategy with a couple of clicks. Basically, it's one click with a couple of configurations that need to be done. So once I have backed that strategy and I want to deploy it, I simply click on it, and if I'm happy with the defaults, it starts trading immediately if you wish for, right? This is what the AI machine is about, and more details are also explained in the Wanda masterclass, because the AI machine is based on Wanda. Computational finance. Now we are entering the options arena, mostly based on derivatives analytics with Python, and we cover there also our open source package, DX Analytics. There's a question related to the AI machine. Yeah, the AI machine is a separate product. It is it's maintained by us, but it's a separate team, separate company, separate product, if the question is asked that way, indeed. Yeah, so here, derivatives analytics with Python, the basis for it, but a little bit more is done there. But first things first, basics here in computational finance, market-based valuation, what this is all about, complete market models. These are the classics, if you like, Black, Scholes, Merton, Coxworth, Rubinstein, binomial option pricing model. We cover risk neutral valuation, Fourier pricing theory, Fourier pricing applications, American options, the general market model, which includes stochastic volatility, jump diffusion, stochastic short rates, quite a level of sophistication and realism, so to say, realistic modeling. But the Carlo simulation here at the core, calibration of models, hedging, review and practice. So particularly here for calibration, I have an example in the demo where you see the code. The code is, let's let's say, quite mathy, math-like, lots of math. Obviously is used here in computational finance, but you will see the results visualized very easily. We have a recent addition to our setup here is listed volatility and variance derivatives, which goes deeper. So it was quite a while until we included this. We had one round. One cohort where a bunch of people were interested in volatility and variance derivatives, and we did this class recently with this cohort. Right here we have the introduction. At the core of the core in this class is model-free replication of variance. It's so important and it's used for everything else that you see there, right? For the volatility products and modeling, for variance products and modeling, right? Also here, when we go to the analytics and what we implement there with regard to these elements, it all starts with a model-free replication of variance among the most robust results in quantitative finance, right? There's a question with regard to the method, whether we do finite differences. Frankly, no. So far, we haven't included finite differences because the whole approach of the computational finance class, as well as DX analytics as the package, which can be used in this context, relies on Monte Carlo simulation because it's the more flexible, more powerful method for multiple instruments, many multiple risk factors for any kind of exercise type, European or American, for any type of payoff, etc. pp. It is simply the most powerful one. So far, I don't know if ever somebody asked me for finite differences. Maybe I listen to such questions and ideas, maybe something that we could at some point also include in this context. So DX Analytics, open source, you find the documentation on the web, right? It's relatively easy to install and it runs in parallel with the computational finance class. So whatever is done in the computational finance part is more or less one-to-one implemented and reflected in DX Analytics. So it doesn't work that it goes really hand in hand, step by step, but overall, so the sequence and the topics covered, such as European valuation, portfolios, Fourier pricing, so short rates, etc., are going hand in hand with what is covered in computational finance. So it's a pretty powerful package. It can do quite a lot. So we can't even explore all the elements of the package, but with regard to computational finance, I think we get a pretty good coverage, plus a couple of other topics such as management of portfolios and a little bit of risk analysis, for example, on top with the package here. So basic idea is Monte Carlo simulation related to the question about numerical methods. It's Monte Carlo simulation primarily. There are also a bunch of implementations based on Fourier pricing, for example, in there, but the primary, the first class citizens, let me put it that way, citizen with regard to numerical methods is Monte Carlo simulation. So we have non-redundant modeling of risk factors. Then we model the instruments. On top of that, we model then the positions, which together form the portfolio. So we simulate the cash flows by Monte Carlo, and then we have backwards induction for the optimal exercise policy and the risk neutral discounting. We can use constant deterministic stochastic discounting in this context. So that's the, in a single chart, the basic idea behind DX analytics, right? Similar here, the pyramid for this class. All starts with the infrastructure. Without infrastructure, no computation, right? Financial data is required as input as well. So if we don't do, let's say, some simplistic model-based simulation, so with sample parameterizations, we need as input financial data, option prices, for example, then the models that we calibrate, then we can simulate calibrated models here in this context, right? So that's the basic idea. We end up with hedging, maybe in the context of DX analytics, also like the management of portfolios in this context, right? Now we come to the case studies and the demos. So what I've done already is point 1 and point 2, so the Quant Platform. Oh, I see here I have still reinforcement learning. I have replaced this by a little bit of math, because I've explained quite a bit and have shown the live example with regard to reinforcement learning. So lots of exposure during the program if you like to do that. So instead of reinforcement learning, I have a math example with me. So speaking of the examples, let me go to my Jupyter Lab. This is not locally. It's not the same as what I've done before in Jupyter Lab. Here I have a more complete installation. And the first Jupyter notebook is about efficient markets. And efficient markets, yeah, what do they say? The basic insight is that there is no value in analyzing the history, the price history, or in analyzing the history of a company, or in doing whatever analysis when we want to predict the future price of an asset. So in other words, the best predictor for tomorrow's price is today's price, right? So that's the idea. And here is a little notebook which does a few tricks which might not be in line with standard assumptions. So to put it the other way around, I violate here a few assumptions with regard to ordinary least squares regression. But I want to visualize what I've just outlined. And here you see it again formulated in its original form by Jensen, a little bit later than the original, the seminal work by Farmer. Jensen says, and I think that's a bit more of a modern formulation, a market is efficient with respect to an information set S. Think of this as a data set, however large it is, whatever it might include. If it is impossible to make economic profits, and that's important, economic profits, by trading on the basis of information set S. There is a difference, and in AI and finance, I emphasize this throughout the book, between having a statistical edge and in having an economic edge. You can have a statistical edge, but then you might also find an implementation strategy which translates your statistical edge in trading into an economic edge, right? And that's the hard part in general, right? You need to include transaction costs, you need to find the right vehicle, which means the instrument to trade, you need to deal with the market microstructure, whatever this might mean, like trading hours and trading rules and pricing rules, etc., liquidity, market liquidity, and all these elements, right? So, but we can, in simply speaking, we can say when we are faced with a data set, right? Whatever this entails, we call the market efficient if we cannot come up with a trading strategy that makes consistent economic profits based on our analysis. Or here, this farmer has formulated this more, I would say more bluntly, I would say. For example, we shall see later that if the random walk theory is an accurate description of reality, then the various technical or chartist procedures for predicting stock prices are completely without value. So chartist and technical procedures, what he means by that is a typical charting where you have a look at the past 20 days or past 100 days. You talk about support lines or moving averages or highs and lows or whatever is included in such an analysis, right? And he concludes here that such analysis should, in a random walk setup or an efficient market, be completely without value. I tell this to day traders who sit hours on end in front of their screen. So I promised I don't want to go into every detail here. It's just to show you a few things. I retrieve here data which is from, did I execute the first? Yeah, just to make sure I've imported everything. I retrieve here data from a remote source, so you can replicate this as well. There's a bunch of instruments contained in here, like Apple, Microsoft, Intel. Having a look at the data set itself, 2,516 data rows. I calculate the log returns. And I can now do some visualization. So we not always, but often use Plotly, which allows for interactive visualization, right? You have here nice D3GS JavaScript-based visualizations where I also can click here and take this out of the mix, for example, do some zooming, etc., right? That's all easily done. You see, it's just my iPlot call. Nothing more is required. of course, you need to install the packages. We can have a look at the histograms of the returns, right? I think at a first look, we can already conclude that they are not really normally distributed, right? Usually we have high peaks and fat tails, but that's a different story that we cover nevertheless in detail as well. Or have a look at a heat map here with regard to the correlations. So we calculate the correlations and then we visualize that as a heat map here, everything interactive, right? We go over that, pretty nice, pretty efficient to do data science with such a setup. Then we prepared the lagged data. This is an approach that is shown over and over again because it's so central to many things that we do. Basically, it on a programming level and here a machine learning level, it mimics the chart analysis. We go X days back in history, like 7 days only. This is just to make the example. 7 days, we can go 17 days back or 170 days if we fancy, but I work here with 7 to make the point and do a lagging of the data. So I have 7 lagged price features, as we would call it, for all my instruments. And this looks like that. So I have the Apple price today and the price from yesterday, the day before, another day, etc. So we now use ordinary least squares regression to do some regression of the lagged data. And we have the non-lagged data as a label here, or as the as the dependent variable we are in this context. We see already the result. So only lag 1 here is of importance to predict tomorrow's price. And this is what was formulated here. In such a case, the best predictor of tomorrow's stock price in the least square sense is today's stock price. So I can do whatever analysis I fancy. Today's price is the best one I can come up with when I want to predict tomorrow's price. And in that sense, I can simply skip my analysis whatsoever, right? So when I visualize that, we see it here now visualized, maybe even more intuitive than just the numbers. It's just lag 1 that is important, right? It's that one. When I get rid of that, here's distribution, but this is all pretty close to 0. When I turn on 1, we see it's the lag number 1. That's enough. When I know lag 1, lag 2, 3, 4, 5, 6, 7 are basically irrelevant for my prediction, right? And this becomes even more so when I go here with the mean values over all my instruments, right? I can also do a little bit more of a statistical analysis. Again, details are not relevant at this stage. We have powerful statistical package here. I'm working with stats models, right, that give us a little bit more of a detailed overview of certain statistics like t-statistics, standard errors, etc., related to what we do in this context, right? So markets are efficient. The question is, how efficient are they, right? And in computational finance, that's one side of the story, one side of the same coin. In computational finance, we take a firm stance in general, not always, but in general, a firm stance in that we say we trust in the markets and we believe in market efficiency. So here we want to benefit from efficient markets. And when we want to price options, here, simple example, simple, it's already quite involved, but simple relative to what comes after that in computational finance. We have a jump diffusion model, and I use this jump diffusion model, which is already quite flexible as compared to the original Black-Scholes model to price an option. So here, this is theoretical valuation. This is theoretical, original research papers, right? I have here the problem. I set up, I don't know, the stochastic differential equation. I derive a solution with appropriate boundary conditions for the stochastic differential equation. This is the formula that we have derived. So that's the formula. Now let's assume that the initial index level is 100, that the strike level is 100, etc., right? This is the typical theoretical approach. I have my model, then I parameterize the model, and I derive the value of a call option in this context, right? But in a market-based valuation context, and this is the primary focus in computational finance, we say we have in general prices for liquidly traded options, such as call options and put options, and I want to come up with parameters that best replicate the prices that I see in the market. So this is now efficient markets used as a leverage to come up with parameters for our option pricing model. How do I do this? Yeah, I minimize mean squared error or root mean squared error, right? So in that context, I simply take the market as a given, the model as a given. What I want to derive are the parameters. So for example, initial index level, this is usually there, and the risk-free return is there as well. And my input values are the option prices plus the strike levels, right? So this is here, this is my universe now that I use for calibration. Or I can say, I could here have a title which says the market. And the market here are call options where we see the market prices for the different strikes, right? And we now want to minimize the model values, minimize the mean squared error between the model values and the market quotes, right? And this is what we do here with regard to the error function. This implements here a root mean squared error. And then I use numerical methods, first brute force, to scan the surface of possible solutions. And you see here, this is the root mean squared error. It decreases here with the number of checks that we have done. We started with 12, and the best currently is 0.97. I don't know when it stops exactly. Here you see it has become better, a bit worse, but here we store the best solution so far. And you see already 1,000 iterations, which means we have here, how many do we have? 2, 4, 6, 8, 10, 12, 13. 1,000 is already 12,000, maybe some 15,000 option valuations have been implemented here, 42 on a regular machine. This is already computationally quite demanding. The best result so far is 0.97. Now we do local optimization. Superman closing in. First flying high above, getting a rough idea, and now you see there are further improvements, maybe not too large, but on that level that's still even 20% roughly, right? And we now get the optimal parameter values that they most probably have nothing to do with the ones that I've used before. So these are the solutions, the 4 values from the first run, and this is from the local optimization, right? And now we can compare our model prices with the market prices, and we see it's not too bad, right? Our model here, red dots, is not too far off compared to the market price. We wouldn't expect a perfect solution. Here we see the differences, much better, but it's also not a biased one. We have positive deviations, negative ones. So this is what market-based valuations is. We derive parameters that in turn best replicate market price. So this is what comp finance is about in this context. We can say in this context, efficient markets are our friend. So we trust in the markets, we use the markets to parameterize our model. That's the idea. Same holds true here for DX analytics. This is now just a standard package that we can use to do what I've shown before. So here I just run through it. Risk factor modeling, you recall this one chart, right? The one overview chart. We have risk factors that we model, right? Low volatility, high volatility, that we add our valuation models for the instruments, right? Can do some typical option analytics here. The Greeks are derived all numerically for different options. Then we put the instruments together into positions, right? Positions. Maybe I pull this up simply because I know really this notebook reflects exactly that. So first the risk factors, then the instruments, the valuation models, then we put these together into positions. So I can have, for example, 10 of European derivative 1, and the 10 would make up my position 1. And then I have position 1 and 2, and the 2 make up my portfolio. So this is exactly the notebook here that mimics or implements in Python code with the package the overview chart, right? My positions, and then I end up with the portfolio, so derivatives portfolio. And then I do the simulation. This is now this part, Monte Carlo simulation of cash flows. And then at the same time, I also do the backwards induction step for the valuation, because I have American exercise here involved. One instrument is American. So we get the statistics for the positions, we get position Vega, etc., and can do some risk reporting, etc. there as well. This is basically a what if analysis. What happens when the volatility of risk factor 1 increases by 10% or decreases by 10%. So these are questions that we can ask, right? Yeah, that's the tool. Separate complete class which covers the basics and advanced topics with regard to this pretty powerful valuation and risk management package. So again, efficient markets are our friend in computational finance, but efficient markets are the enemy of the algo trader, right? In algo trading, what I want to achieve is a victory over efficient markets. So we want to achieve superior returns, returns that are beyond the typical risk adjusted returns that I can achieve by, let's say, standard asset management techniques. Right? We want to beat the market. Let's simply put it that way. We want to realize alpha in this context. Right? And in that sense here, I show one notebook, which is about financial features that we can use, simple ones, and to implement a market prediction based on machine learning, deep learning approach. So I import here data from Wanda. So these are 15,456 lines of data, right, that we have in here from a period January 2018 to March 2019. And I come up here with financial features that are all derived directly or indirectly from the price data. So again, with regard to reproducibility, we usually focus on features that can be derived from original data, and this is usually or primarily this is price data. So we can derive returns from the price data, right? We can direction derive there. I have open, high, low, close data. So here I derive the difference between close, open. For example, I derive volatility values, simple moving averages, time series momentum. So here it's basically, it mimics what day traders do with regard to technical analysis, charting, etc. Right? So I can define what I consider important, and this is what I will feed the machine learning algorithm in order to come up with predictions. So it's automated technical analysis, to put it that way. We have stuff here that can go easily beyond what is possible with visual technical analysis, but we can mimic basically everything that a technical trader does here as well. So our feature list is there now. We have the features given. We have our data set, 15,000 data rows. We do a split in training, validation, and testing. I work with 10 lags. You recall the efficient markets Jupyter notebook, right? I do a Gaussian normalization and do this for all the features, and I treat some of the features differently here. This is the if else clause here. So I do normalize and lag, and afterwards I have 210 different features, right? Lags plus the features, so we can multiply that 10 lags times a bunch of features that we have just defined above here, right? So maybe I show this here as well. So length features. 21 times 10 makes 210, right? So such a data set looks as follows, right? These are now pretty large data frames shown here. Therefore, I have usually commented this out. And I now work with a deep neural network from scikit-learn. I do a model fit based on the training data set. So my hope is, that's my hypothesis, that my machine learning, deep learning algorithm can learn about typical trading patterns, right? I don't need to name the patterns. I don't need to teach the machine what pattern to look for. If there are patterns in the data that allow for proper prediction of the future market direction, then the deep learning model should learn it, right? And here I translate the predictions into long and short positions. I come up with my strategy returns, and I see here, yeah, the benchmark investment loses a few percentage points, and my strategy, without transaction costs whatsoever, gains a few percentage points over that period of time. So we do quite a bunch of trades. Mostly we are short, and what we see here is the benchmark investment. Again, all no transaction costs whatsoever. So it's rather simple. It's only about the statistical edge. And here we see my strategy going up, up, up. So when I emphasized this before, statistical edge, economic edge, this is the starting point. This is about statistics only, right? Now, here we would say, okay, this is good enough. Maybe we do more analysis, maybe remove features, maybe we add other features, maybe we try another algorithm. And once we are after the research phase, we are convinced that there is something to this strategy, we can then say, and this is again one of the major goals in the Python for Algorithmic Trading program, we can then say, oh, okay, now let's deploy this strategy for trading. And at this stage, and this was a little bit of a critique about the history of Quantopian and maybe some other places where you can do backtesting, that not every such platform allows you then to seamlessly move on and transition into a deployment setup, right? Here we see the numerical results, but yeah, we want to deploy it, we want to run it, we want to benefit from it, we want to beat the market and make economic profits, right? When Pharma was writing statement in the 60s, there hasn't been like my MLP classifier model, deep learning techniques around, right? Maybe back then this was a perfectly valid statement, and with ordinary squares regression, I cannot do the trick, but maybe, who knows, with AI, machine deep learning, we can beat the market, we can overcome the course of efficient markets. So at this stage, we would then say, all right, that's fine. We have done the preliminary work. We are convinced that this is something good, and we can then move on towards a platform. So a platform such as Wanda, which we primarily use. And recently there was a question in the user forum, why, Eve, do you recommend doing FX trading, etc.? Is it due to transaction costs or what? I said, no, primarily it is due to the platforms based on which you can implement FX trading. CFD trading, for example, is in many jurisdictions not allowed anymore these days. But for example, Wanda has a pretty good, I would say the best API, best REST API that you can get as a retail trader. And that's the major reason, is technology, right? It's not this web interface. I just pulled up the web interface here where you see your US dollar, Brent crude oil, right? This is going on in 5. So here, just having a look, you can do your technical analysis, some simple moving averages, maybe some momentum parameter, all interactive. I can add or remove statistics. I see my positions here in, for example, BCO US dollar. But we want, of course, in algorithmic trading, maybe this is a nice interface, but we don't want to click here and say buy, sell, right? When I click on buy here, it allows me to buy. This is the traditional discretionary trade. I can say, okay, submit, and I start trading simply by clicking around and confirming stuff and maybe closing positions, etc. But we want to work with APIs, and Wanda has a great API. So we need to connect to the API. That's usually just a matter of a single line of code. You need to set up a paper trading account, which is completely free but has full functionality. And once you are connected, so this was more or less immediate, you can see, for example, the instruments. Here in my account, there are some 120 something instruments, right? For example, here a CFD instrument on the S&P 500, or here on the FTSE 100, many currency pairs, West Texas oil, also commodities like wheat or gold, German DAX index, interesting for me as a German, right? France, Europe 50, this is the Euro Stocks 50. So quite a bunch of instruments, but I want to focus on currency pairs. So I go with Euro US dollar. I retrieve just like data from last week, right here, 13th of May, 1 minute bar mid price. And you see this almost instantly. I get here the data with a paper trading account only, so no subscription required one. And I get returned here 1,399 data points, right? 1 minute bars. And this for 1 day, 1 trading day here in this context, 13th, right? And I now backtest the momentum strategy, very simple strategy. So I simply say when the time series momentum is positive, I go long. And when the time series momentum is negative, I go short. So one of the most simple strategies that you can implement. And I can analyze things like the hit ratio, right? So false, doesn't really work in the beginning. I have more falses than trues, so it's just a hit ratio of 46%. And I do my vectorized backtesting, something we absolutely focus on in this class, in the algorithmic trading class, right? And I can now backtest it. So I haven't really tweaked my example. I just wanted to have some very recent data set, just like before the weekend, right? And I see it's not a wonderful strategy, but at least what we can say and conclude is for this trading day, the strategy outperforms, not including any transaction costs. Again, this is simplistic, just statistical view, outperforms the passive benchmark investment. That's good enough for me, let's say, right? And I can, for example, also show now here for a selected few of the data points where and how trades take place, right? So here we see like the positions changing from +1, which is long position, to -1. So it trades quite often, well too often. It can't really earn the transaction cost, but this is excluded or assumed away, let's say, at this stage at least, anyways. Right. So I have, with the API, with my paper trading account, full access to all the historical data, so dating back many years, down to a level of 5-second bars. I can retrieve data, can do my back testing, can maybe add proper transaction costs. And then what I said, well, at this stage, we now need to be able to trade, right? Here in my paper trading account, there's one position, BCO, US dollar. And when I now here create an order, Euro GBP, just 100 units, I get back again almost instantly here a larger object, a JSON object with all the details of my order. And now let's have a look here. And suddenly we have a second position, Euro GBP, 100 units long, and I've executed my order. So I have now the major ingredients, right? I have a strategy maybe, I can execute trades, so I have opened a position, I close the position, yeah, right? Close the position has vanished, right? Like magic. I don't need to click buy and sell anymore. And as soon as I have this capability, I can now run this in a loop. I can implement my trading logic, and from the Python level, I can trade easily and implement my trades here, right? As you see, this is from today, so I checked whether everything is working before our session, and here are just the 2 trades that I've executed. This is GMT time, I'm CEST, so there's a 2-hour difference, 14:35. This is just what I executed before. The opening trade has no P&L, and the second number here is the P&L. It loses a bit, but alone due to the bid-ask spread. And if we want to do this in a continuous fashion, we need to be able to stream data. And here you see now a stream for Bitcoin. US dollar prices has come down a bit given to the recent comments and tweets by Elon Musk, and changed his mind with regard to Bitcoin acceptance as payment means for Tesla, and there was a little bit of a Twitter exchange over the weekend, so prices come down a bit more, and here we can stream the data. But I can also stream, of course, what I've analyzed before. Euro, US dollar, I can stream. There's not that much action. It depends on the time of the day, right? Euro, US dollar was faster, and the other instruments as well that I've shown there. So I get real-time data from that as well. We have now all the ingredients together. Of course, there is quite a bit of code missing in order to do automated algorithmic trading, but you see we have the ingredients. We have all the data that we need. So maybe I go to the respective slide. Jump. Here we have the infrastructure, right? We discussed this. All the financial data that we require, we can implement the strategy code. Pretty simple, more sophisticated, technical, non-technical, machine learning, non-machine learning. We can do the backtesting. We connect. I've shown the streaming to the API. I've shown that we can retrieve via the API the financial data, and then we can implement the trading code. This is the part that I've not shown. It's a bit more involved. I mean, trading code, yes, I've shown the simple execution here, right? This is already trading code, but not automated trading in that sense. And last but not least, we need to make sure that the algorithm is implemented and monitored and maybe risk managed in a proper way automatically by a Python program, so that we don't need to sit there all day long and watch it. Maybe only if there is an exception that we get notified through the monitoring mechanisms that something has happened. So that's the basic idea of all of this. And with the platforms such as Wanda, we have all the instruments together. Even if CFD, FX trading in that form, is not available in every jurisdiction, I think it's fair enough that you maybe set up a paper trading account for another jurisdiction to simply try it out, like by other jurisdiction. I mean, a German paper trading account to test it, or a UK account to test it. But of course, depending on your jurisdiction, I'm honest at this stage, you might not be able, for example, to do CFD trading, what we cover in this part. But we cover interactive broker, stock trading, basically active around the world, Gemini, etc. So there is a bunch of other venues that you can choose, and so many others are now following suit and coming up with Python APIs, because this is the #1 language in algorithmic trading, not only for the pros, but also for retail algo traders and quants these days as well. I said that we will put a bit more focus on math this time around. And by math, I don't mean like a classical math lecture, but how we can use Python with regard to mathematical problems, questions, and topics efficiently. So that's the basic idea here in this context. And I've just picked out one topic from Python for Finance here, which is SymPy, which allows us to do symbolic computation, like we use from high school, college, a master's program, where we say, well, we are dealing with certain variables, x and y. I come up here with symbols. And you see, this is not a traditional Python variable anymore. This is now SymPy core symbol, right? This is a specific thing. So I can, for example, now define the square root of x, which is now really symbolic. It's the square root of x, right? Or I can define something like a more complex form here, where I say, well, 3 minus 4 squared, and I have my square root of x still as before, and you see it simplifies it already automatically, right? It collects the two numerical terms there. Or I have something like an expression here, a function, and I also get here the simplified version, 1.5 x squared plus 4.5, and this for sure is not the version that I've passed here, right? You see it simplifies it on the fly. I can also use ASCII printout here if I prefer that, in a sense here, right? You see the ASCII printout instead of the nicely rendered LaTeX. With math checks, I think in this context, SymPy allows me to do so many things, right? Here we have, for example, what I do here is I create a string out of the number pi which is evaluated to 400,000 digits, right? The traditional problem. This is pretty fast, a quarter of a second, and I get a string with 400,000 digits of pi. So here it's the starting point, right? And these are the final 40 digits. So there's a well-known result that every date of birth is contained in pi, right? And here is, for example, date of birth, 6th of October, 72. And I can find this pretty quickly. And at the location 80,847, there is the date of birth. So you can check that. There are websites, if you're interested in that, to check your own. Either use the Python code here, do the Python code here, or there are websites out there. I think if you Google that, it's easy to spot, right? Yeah, there's somebody asking, what is the difference between this and LaTeX? Yeah, here, this is doing the math itself. I have something like capabilities to come up with mathematical equations displayed here, but SymPy allows me to do math, real math with the equation. So, for example, here, when I come up with a simple equation, x squared minus 1, so when I interpret this as an equation, this would be, so now that we have had this LaTeX, so my equation here would be x squared equals 1, right? So this is the equation, and for the solving, I write like here. This is the same as minus 1 equals 0, right? Oh, I need one more break in between, right? This form equivalent, and that's the form I need to write down my equations that I want to solve. And here's the x squared minus 1, and this solves the equation, right? It solves for the two solutions of this quadratic equation, minus 1 and 1, right? And I go with 4, and so we do math here. A little bit more involved, right? I don't need to come up with like the simplified version. I can go with minus 4 here as well, right? What I did before, or solve the equation here, a cubic form, x to the power of 3 half x squared minus 1. So for cubics, we can be lucky. Here you see it has complex solutions, one real solution and two complex solutions. That's the capital I here. Or I solve for equations with two unknowns, x and y, right? And we have also here complex analysis involved, right? There's somebody asking about complex variables. Yes, you see, we have already examples here with, I'm happy a few of you have commented this is all cool, and I think it's indeed cool, right? Also, when we do stuff, I mean, there are many more examples with SymPy, but integration, for example, is a typical problem, a typical mathematical method that is used all over the financial theoretical landscape. When I come up with two symbols here, a and b, and I can, for example, define here an integral over sine function. I can even now do my pretty print here with the integral. This is in the ASCII mode here, right? And I've chosen ASCII mode here explicitly because this originally was a part of a book, and this can be then easily translated into proper ASCII characters, which can then be printed in a book context quite easily without mass checks rendering anything, right? But not only that I can display here some integral, might not be the nicest way. I could go back to the original way here, right, where we have mass checks rendering it like LaTeX, but that's not the major point. The major point is that I can define based on such a function here my integral function, and I get indeed my solution here for the integration, right, where I can evaluate easily integrals numerically, right? The one thing is that we have some symbolic what's it called? Some symbolic adjustments, simplifications, changes, manipulations. This was the word I was looking for. Symbolic manipulations, right? Or visualization. That's one thing, but in practical situations, we want to do the calculations, right? And this is what is now shown here in the more involved way. So when I add my limits here, I can solve this also a bit more easily when I substitute for a and b. It calculates the integral function here as well, or I go directly and specify a and b numerically, and I do my integration. So here, I think this is the final thing is the most natural. I say integrate SymPy sine x plus a half x over x limits 0.595. It gives me the solution, the numerical solution for the integral. Above here, how I get started, I haven't specified the integral limit, so it treats the whole integral in a general way. Once we get to the level where we specify the integral limits, it solves it numerically, right? So pretty nice and cool, as some of you have commented in this context. Yeah, more on that during this cohort for the first time, a bit more for focus as a refresher, or maybe some additional tricks and tools that come in handy and are beneficial for what you do in the other parts of the programs, or maybe on their own. I mean, often you have an issue, maybe not related to computational finance, but more generally, and then of course you can rely on that as well. Yeah, this was the quick review of the pyramid for algorithmic trading. We have finished the demos. Here there is the link to the gist, which you have, which contains the Jupyter notebooks. So here the Jupyter notebooks are in there. They don't render when there are too many Jupyter notebooks. The gist doesn't render anymore. But in this gist, you have all the resources that I've now shown are in there, right? So study plan. Study plan, if access to, there's also link behind that. First page maybe not as relevant, but in this week number 1, where we now get started, we have finance 102, where you should also read the relevant parts in the books. I've shown you on the Quant Platform where you find these elements. You can, for example, safely skip the asset management class and do this later, because this is, I said, a comprehensive class. But if this is the primary reason why you started the program, you should, of course, follow that. Then we have here in that part the live sessions, intro and overview with math basics, and a Q&A session on Discord this week. Financial data science covers data types and structures, and you should read the first and second chapter. Then tools and skills about Python environments, the very basics. AI in Finance book has AI in Finance 1 plus chapter 1 in the book resources. Optionally, you can do AI in Finance 1, and you can maybe get started with Excel, because Excel, the Excel class in the beginning, works with plain fundamental Python code only. There's the Python part here is not the major one. Maybe setting up everything properly is it's much harder, I would say, than the Python stuff that is covered. But you can safely do Python for Excel 4 weeks from now. You wouldn't miss anything in this regard if you skip this for later. And so next week, structure similarly, right? And so we go on until in week 4. So the structure of the program is basically that every 3 weeks can be seen somewhat together. Not exactly, but there is a milestone after week 3, there's a milestone after week 6, and there will be review questions for these blocks of 3 weeks. So it's roughly that way. Of course, it goes seamlessly over each other, but from week 4 on, we will have the separation algo trading and computational finance, right? In the beginning, focuses on laying the foundations for everybody involved, so that the first milestone is that we finish up this basic first phase of the program, right? If you have questions, feel free to ask them in the user forum or in the Discord, on the Discord server during the Q&A in this context. You have many opportunities, as you see, to get in touch with us in regard, right? The numberings, yeah, numbers correspond to the video. So when there is finance with Python 01 or 2, this means you should watch the finance videos 01 or 2. We can also say modules because they're not only videos, there are associated or attached resources, modules, recordings. This is what is meant by that, right? Another question, how long after the program will have access? Yeah, you will have access indefinitely to your resources. Not everything that we come up with in the future might be part of your program, but to your own resources, you have indefinite access. If you want to study all year long and want to repeat next year, January, you can do that, right? So we don't close down accounts or access in this context. Guiding principles. So I've recently created this slide because I said, well, sometimes people ask me, what is your approach? What differentiates your approach? Because we cover so many topics, and sometimes people ask me, and I want to get clear about this, what algorithmic trading strategy do you teach us? What do you recommend? And this is not the primary business that we are in, right? So we are here in a Python first business. So coding and implementation are the focus rather than theory or practical consideration, which means that we show you how you can formulate your own trading strategies, how you can backtest your own trading strategies, and how you can deploy them. But we are not in the business of selling strategies or recommending strategies or whatever. We are in the business of teaching you all the skills required for you to implement what you want to implement. Right? That's how I would like to be measured in this context. And we do this in a very specific way. So it's not that we have like traditional lectures, 120 slides with theory after theory. It's basically everything that we do is specific. So algorithms shown and examples shown are specific in nature and not meant to provide an exhaustive overview. So we simply cannot do this. There are like books about deep learning that have 700 pages, right? How should we do this in that period of time? We can show how to use Keras and TensorFlow to implement dense neural networks, recurrent neural networks, and convolutional neural networks. This is what we can do, but we cannot go into every single detail what is related to, let's say, convolutional neural networks. We provide the most important background details, but not everything. Most of it is really specific. Reproducible. You've seen this already. All my examples have been reproducible in a sense that they rely on static data sets primarily. Of course, when we get to the point where we connect to APIs and to real life trading, that's hardly reproducible because we cannot get back in history and redo it over and over again without the time machine being invented. So let's say the 95% the examples are reproducible because we provide all the data sets that you can work with to get started with. Not meaning that you shouldn't try to use your own data sets if you have interesting data sets that you want to use for the analysis implemented. And last but not least, to the contrary, I think it's the most important part. You can basically, from my point of view, don't take me on my word here, but you can skip half of the recommendations, the reading assignments and the recordings, etc., if you invest the time in practical coding, right? What the major goal is to acquire coding and other practical skills. That's the major goal. Skill acquisition is indispensable. It's not about seeing something, hearing something, learning about something. It's about doing it, right? My standard example is you cannot learn to swim by reading a book about swimming. You might get an idea, but you need to jump into the pool at one day and you need to get started swimming. The same holds true for driving a car and anything else, playing the piano, you name it. I see programming primarily as a skill-based discipline and not as much as a knowledge-based domain. So if you want to learn about the research results that have shaped my thinking in this regard, primarily it's here the book Peak Secrets from the New Science of Expertise. And I recently had maybe I thought it was a little bit rude, but it was somebody who said, well, do you know this on Twitter? Do you know this feeling when you stand in front of a group or larger crowd and you're supposed to do some live coding and you can't even type a single line of code? Who has experienced that, right? Do I need to try to achieve mastery in this regard? I said, well, I personally see this as a good benchmark. So my example was, think of Lang Lang, the famous piano player. He's only famous because he's playing in front of audiences and because he's teaching master classes, right, to other students, right? If he could only play the piano back home in the basement, right? Nobody watching, nobody listening, nobody, then he wouldn't be the player that he is. And I think with programming, at least to a large extent, you should do it. You need to do it, and you also need to strive, like as a teacher, to do it in front of others. You need to maybe record yourself and see how you type. And so this is my major message: see it as a practical program and do as much coding as you can, and rather skip a theoretical element and do more coding if you need to prioritize. So speaking of practice, we have come up in the past with review questions for the different parts of the program, right? Which allow you to think it through, to come up maybe with some notes where you say, well, oh, I don't recall this, but this is important obviously to me, so I need to review certain elements. So this is more about thinking, reviewing, making some notes. But the major part here in the tutorials part is to solve exercises that are sometimes pretty close to what is covered in the class itself, and sometimes some challenging and hopefully a bit of fun projects which are beyond of what has been covered at this stage, right? This is where you should really put emphasis. I mean, it's not a big deal if you skip 1 week of exercises and do it a little bit later. That's not the point. You don't need the exercises to move on with the assignments, right? But you will, I think, notice that it helps you tremendously improve your skills instead of just having seen something done by somebody else in this context. If you have questions, and everybody has questions and faces issues, use the user forum. I've shown the user forum. Feel free to do it. So usually we try to get back as quickly as possible. Sometimes, I don't know, on the weekend or when there's difference in time zones, this can take a little while, but I'm happy that our community is growing in a way that many of our recent delegates are happy to help out here as well with certain questions. So put your technical programming questions here in this forum. But if you do so, do me one big favor and listen what I say now. I'm not willing personally, and that's not by ill will or whatnot, to answer questions that are not properly posted. Sometimes people say, well, there was this session. I don't even know the number where I executed the code that you have shown, but I replicated it perfectly, but it doesn't run and throws errors. So this is now an extreme example. We've never had something like this. But sometimes people post 2 lines of code and say, well, this doesn't work, and we can't really see what the issue is because the data set that is used is not related there or shown, right? It's not what is called here on Stack Overflow a minimal, complete, and verifiable example. Whenever you post something which is code related, please make sure that it's minimal. Use as little code as possible. I mean, there's also a problem. Sometimes people post 250 lines of code when there's an issue with regard to 2 lines only, right? Use as little code as possible that still produces the same problem. It should be complete. So I want to do copy and paste and want to replicate it by myself on my machine. Complete. Minimal, complete. Verifiable. So the code should really reproduce the problem. And always, if you are not sure, you should, before you post it, you should post or check your minimal, complete, verifiable problem on the Quant Platform in Jupyter Lab so that I can test it there as well, right? So please make sure, because usually when it's not minimal, complete, and verifiable, I simply post the link here to this page on Stack Overflow, and they have millions and millions of posts, right? So it's not that we are lazy or whatnot. It's simply impossible. In many, many instances, it's simply impossible that we can help if it doesn't satisfy these requirements. Last but not least, with regard to community building, supporting you, making it possible to get the best experience out of the program. We recently started also based on requirements, and I really love it. I've become a big fan. We started Discord servers where we do regular Q&A sessions, so live sessions where I'm sitting there for an hour and a half, or if there are more questions, longer, and answer all the questions. Not the programming ones, right? You know by now the programming ones, they are supposed to be put here. And this is much faster than anything else. Discord doesn't really work well when you want to share code and want to discuss code. You can do a study group there in a live channel, right? That's not the problem. But for technical problems, user forum. For everything else, it's about the Discord server. Everybody should have received the link. Only thing that you need is an account. You can use it via the browser, but from experience, the desktop app, which is available for all major platforms, is possible. So we have started a new server for this cohort, and we will add channels. There we usually have Q&A channel, coding questions, programs. What I usually add something about hardware, because usually there are questions about hardware or infrastructure, right? So as we go, we can, have and do ongoing chats. But what we will have are regular live chats where you can ask and bring your questions, which are beyond the technical programming ones, such as later on maybe people ask questions, many questions about the final project, how this works, or maybe you really have a question. Well, I'm currently in the process of deciding for a new laptop that I want to buy, and all these questions, right, related to that. Or we have regular discussions on the other servers with regard to trading strategies and job topics. All these questions you can bring here to the Discord server. Yeah, would be happy if we can build and form our community and support the community, and that you can support each other maybe here on this wonderful and powerful platform. Yeah, this brings me to the end of today's introduction and overview session. You see, we have I think a few very exciting weeks in front of us with many topics to cover. If you need to prioritize, think practice and skills first, knowledge and watching videos second. But of course, you first should soak up all the knowledge that you can get and then get started immediately with practice, right? Think of the piano teacher who plays like a piece first and then you try to replicate it. That's, I think, the very approach that you should strive for. So for me, it's always exciting to get started anew, also with the new stuff on the horizon, with a bit of more math as before, some other ideas for upgrades, building the community via the forum as well as the Discord server. And yeah, for me, it remains to wish you all the best, to have a great start, and that you get all the benefits out of the programs that you wished for. If there are questions, I know you know exactly where and how to formulate and put them. And again, I see you in the next session. All the best. Have a great start. Bye-bye.